function f, which is a function of rho pi z, is given in the question, then which one of the following is true? Here, div f is going to be 1 by rho dou by dou rho rho a rho plus 1 by rho dou by dou pi, that is f pi, here that is d rho component, this is d pi component, 1 that is dou by dou z dz component. Okay, means if it is d. Now divergence of f is nothing but here d rho component is this, that is it is going to be rho square to rho 2 plus this is going to be sine 2 pi, this is going to be minus 1, hence 1 plus sine 2 pi is the divergence of f. So divergence of f at pi equals to 0 is 1, divergence of f at pi equals to pi by 2 is 1, divergence of f at pi equals to pi by 4 is nothing but 2, hence divergence of f at pi equals to pi by 4 is nothing but 2 divergence of f at pi equals to 0, hence option D is correct. Here the question is, the band structure of a bipolar junction transistor is shown in figure. It represents, here this is the Fermi level closer to the valency band, means till this particular point it is a P type of semiconductor. Here the Fermi level is closer to the conduction band, means this is kind of an N device. Here also Fermi level is closer to the valency band, that is this is P. Now here this one, the Fermi level in this one is here, and means this potential, this is nothing but VCB. Here this is means the difference between these two Fermi levels is VEB, means this is means this potential is more reverse biased. VCB is greater than VEB, hence the collector junction is reverse biased, then the forward means emitter junction is forward biased, means it is PNP BJT and biased in active mode, hence option A is correct.
Let's look into this problem. It is given that X is a non-zero column matrix with n rows and n is greater than or equal to 3. So the minimum matrix is third order. Then the rank of the matrix X into X transpose is what? So X is a column matrix. Let us take a column matrix with n rows. Right. And the elements be some 1, 2, 3, so on up to n. This is X. Now X transpose will be again 1, 2, 3, 4, so on up to n. Now if I find the product X into X transpose, this will be 1 into 1, same, so on up to n. Now second will be 2 times of all this, 2, 4, 6, so on up to n. Next, that is 2n. Next third will be 3 times, 3, 6, 9, so on up to 3n. Similarly, n will be n times n, 2n, 3n, so on up to n into n. Now, if I apply row operations, let us say R1 tends to 2 times of R1 minus R2. Similarly, R2 tends to so on up to all these things, up to n minus 1. So all these terms will become 0. All the values will become 0 to n, and here also, but only n, 2n, 3n, so on up to n square will be left. That means there will be only 1 by 1 matrix, where non-zero 1 by 1 matrix. So the rank of the matrix is 1. So answer is option B.
Question is, how many different states can be generated using a modern counter? Suppose, see, if this is the counter whose value is mod n, means it is going to have n different states, then only we call that counter is having a mod n number of states. So the number of states are going to be less than or equals to n. It is equality condition, so just indicate only when, hence option A is correct.
It is given that f of x is equal to 0 is a transcendental equation with the sequence x0, x1, so on up to xn. Now approximation which is given as xk plus 1 is equal to xk minus 1 f of k minus xk f of k minus 1 by f of k minus f of k minus 1, such that f of k into f of k minus 1 is less than 0. That means negative for all k, where f of k is nothing but f of xk. Now he is asking this schema is known as what? Now clearly it is nothing but false position method. That is option D. When there are 3 students x, y and z write an examination, their chances of passing are 1 by 2, 1 by 3 and 1 by 4 respectively. Now we have to find the probability that at least 2 of them will pass. So probability of passing of x is given as 1 by 2, probability of passing of y is given as 1 by 3, whereas the probability of passing of z is given as 1 by 4. Now the probability that x will fail is 1 by 2 again, probability that y will fail is 2 by 3 again, probability that z will fail is again 3 by 4. Now is asking probability that at least 2 will pass. That means minimum 2, that is 2 will pass, probability of 2 passing plus probability of all the 3 passing. Now let us look into probability of 2 passing. So when it comes to 2 passing, it may be xy may pass, or yz, or it may be zx. Now if it is all the 3, x, y, z. Now if x and y are passing, then z must fail. If y and z are passing, then x must fail. If z and x are passing, then y must fail. Now let us substitute the probabilities of all these values. That is 1 by 2 into 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 4 into 1 by 2 plus z 1 by 4 into 1 by 2 into 2 by 3 plus 1 by 2 into 1 by 3 into 1 by 4. If we simplify, it will be 7 by 24. So the required answer is option D.
Here the question is, the KCL and KVL are based on law of conservation of dash and law of conservation of dash. Here KCL is nothing but, suppose if we assume this node means it is an algebraic sum of all the currents leaving that particular node, means current is nothing but a flow of charge. So it is law of conservation. KCL depends based upon the law of conservation of charge. Now if we comes to KVL, suppose this is a loop, it is so algebraic sum of all the voltages in the loop is equals to 0. That means voltage is nothing but a current flowing through the any passive element, means it is an accumulation of charge over the time. It is kind of an energy. Hence the law of conservation, that is KVL depends upon the law of conservation of energy. Hence option D is correct.